How's it going, guys? My name is Felipe from Flow Foundation, and today I'm going to be teaching you about the new stuff we're bringing here on Flow, specifically with the Flow Forte network upgrade. There's two things I want to show you guys today. One of them is flow actions, and the other one is scheduled transactions. So, you can check out all the documentation. It's live on our page, and if you want to check it out and have a bit more details. So the first thing we're going to look into is scheduled transactions. It's basically cron jobs that are on chain. They live completely on chain, and they remove any necessity in order to create external servers, depending on third parties, and making sure that everything is on chain and completely secure and decentralized. I'm going to showcase a bit about what we can do with these scheduled transactions. So I'm going to go here into our scaffold repo, and in the interest of time, I have already gone through and done most of the steps in order to have our emulator account, which basically functions as like an anvil. If for those who are familiar with Solidity, especially with Foundry. But yes, so the first thing we're going to do is install our dependencies and initiate our emulator. So while this is happening, I'm going to be talking a bit about what we are doing. So we have this emulator running on, and we're checking the logs each and every second, each and every second. And so basically, what we can do now with this is once again, everything here is in our documentation, and you can find it within the scaffold repo as well. So basically, what we have here is our emulator that is running in this section over here, and we can execute a transaction that will be scheduled in an automatic manner. It is like a cron job, once again. We will initialize a handler that will execute this for us, and then the base contract we're using here is a counter contract. It's a very simple contract that just increases a counter, and we execute a transaction in order to increase, and then we can execute a script in order to read that data on chain. So in this case right here, we have the emulator running in the background. So we're just going to go ahead and execute this transaction. Okay. Perfect. And as you can see, we have a scheduled transaction to be executed. And then we can see this script, and we can see the counter has increased to 1. Before it was 0, now it is in 1. Now you might say, this is pretty simple, okay, but this is where things start getting very interesting. We can schedule these transactions to occur in a loop. So I'm going to run this next transaction that will basically increase the counter every 2 seconds. We're going to go back to our emulator. As you can see, it increases the counter, which with the scheduled transaction every 2 seconds. This might be interesting in order to set up a form of subscription-based payments. If you subscribe to a service, you can schedule a transaction that you pay for that service every month. These are made by Unix timestamps. But yeah. And as you can see, like the only thing you really care about is giving the contract that's executing these transactions enough gas for them to be executing them over and over and over again. And it will go ad infinitum if it has enough money. And remember, like $1 will basically grant you the ability to deploy 20,000 contracts on Flow. So it doesn't really take much gas at all to execute these cron jobs. And this is way cheaper and way more efficient and just simpler to use overall than the third-party alternatives in which you depend on a server somewhere else, which it's not very decentralized nor safe. But yeah. So then we also have this next one where we can schedule a transaction to occur in a specific interval. We want it to be in a 3 second interval. It's precisely for a specific amount of time, and then it's going to end there. So we're going to execute this transaction. And we're going to go back to our emulator to look at the logs. There we go. So this is the execution of the scheduled transaction. As you can see, I restarted the emulator. So we're going to see how the count was first at 0, now it's at 1, 2, and now 3, which is what we specified directly within our transaction. Unlike Solidity, in Cadence, you can specify multiple calls within a single transaction. You can specify who has access to what. So in this case, we are specifying that the transaction handler specifically will have access to execute a specific amount, send a specific transaction at a specific amount. So we really care about granulating the control, giving access control detail to who can do what. And this is the beauty of scheduled transactions. It's simple, it's cheap, and it's easy. This can be also played around a lot with DeFi protocols if you want to be able to move around money. For example, every X amount of time you want to restake your funds so you can optimize your yield. You can optimize your portfolio in certain ways depending on how you want to harvest your fees. But yeah, once again, all this is on the documentation site. Please look at it. I feel like you guys will have a great time playing around with this. All right. Okay, so the next thing we're going to focus on right now is flow actions. And basically, okay. So the next thing we're going to focus on right now is flow actions. And these are basically 5 DeFi primitives that we have worked on here on Flow. So instead of having to build, a connector for every single protocol you want to interact with, we have abstracted this away where we only have to use 5 DeFi primitives. You can use source, which is one of the primitives, sync, swap, flasher, and price oracle. So source, you're grabbing funds from somewhere. You're pulling funds from somewhere. In syncs, you're depositing funds somewhere. In the swapper, it's as it sounds, you swap one asset for another. In the price oracle, you're just getting the information about the price of an asset. And the flasher, it just functions as a normal flasher. So instead of having to build, a connector for every single protocol, we have abstracted out of the way where in a single transaction, you can build and link these complex DeFi workloads in a single transaction. What I'm going to show you guys right now is basically a restaking flow action. So I'm going to go here to increment Fi, which is one of the protocols, DeFi protocols in our ecosystem. And we have this staking pool. So basically what I have done here is I have staked, I had a flow, and then I zapped into a staking position. What this means is that I grab my flow, and then I put it into this pool to stake it, and then I receive the LP tokens for staking it. And then I can grab those stake LP tokens and put them in this farm, right? So we have an LP pool right here. Specifically, this is the amount right now I have staked, and this is how much I have earned so far. What I want to do is be able to pull these rewards, which is the staked flow. I want to convert it into staked flow and flow so I can put it back into the LP pool. This way, I will have an LP token, which I can put it into this LP pool. So once again, I'm sourcing the funds from this LP pool, and then I'm zapping into the staking position, and then the LP tokens, I'm putting them back into here. So I'm basically restaking this. It's a very complex workflow, but if you're probably doing this, you'll think that you'll do it every day. You won't do it every day. You'll forget completely. But here you're doing it in a single transaction. So that's what I want to show you guys right now. All right. So the important thing to do to understand here is how transactions work in Cadence specifically. For example, in this section over here, I have a transaction that is what we are going to execute. And I have this user certificate, which is a user certificate generated every time you use the protocol. So in order to get one, you can just run this script within the Flow runner. Once again, all this is in the documentation, so you don't have to, try to memorize anything. You just have to run it, and then you'll get your user certificate, which will live in your account. But yes, and then we have our pool, which is the specific pool we're interacting with. In this case, it's this one right here, the Flow staked Flow pool, which has the number 204. And then we have our starting stake, the swap source, right, where we're pulling the funds from. And we have these things that make us allow us to have more granular control over the security and success of our transactions. We expect to have a specific amount of staked increase through this operation, and if we don't achieve that, then the transaction will not occur. So this allows us to make sure that all the funds are being used, there is no dust, remaining, and we have a high optimization over our yield. And then finally, we have this operation ID, which is basically the way we're going to link these complex positions and workflows so that they can execute in an atomic manner. There's three parts to a transaction on Cadence. The first is the prepare. You basically specify who has access to what can access what can be sent to what. And then once we have specified that, then we go to the execute phase, which is here, in which the actual transactions are being executed. You have multiple calls that can be executed. And finally, you have the post phase, which is you ensure that certain conditions must be met, or else the whole transaction will be reverted. But specifically, let's look a bit into the prepare phase. So here we are looking into the pool. We're specifying which pool we are interested in. We have the pool ID, which is this PID. In this case, it is the number 204. And then we have the starting stake, the user certificate, which I mentioned before, and the operation IDs. And these are going to be created for each position generated. Then we just have some fail safes. So when you enter the LP position, you want to make sure that the proper ordering of tokens is executed, and if not, then it will revert them. So it will change the order so that the transaction will occur. And then here is where we are grabbing the rewards from the source, right? So it will be this LP pool specifically. We're going to grab those rewards. That's going to be our source of funds. This is where the funds are coming from. Once we have that, we're going to zap them into the liquidity position. We're going to convert half of that staked flow into flow and staked flow so we can enter the LP position. And then finally, we are going to source the output of that, which is going to be the LP tokens itself. We're going to grab that so that we can direct them directly into the farm once again. Once we have all of this in place and we have all the fail safes that we have, then we can just run the transaction. So here, this is the transaction I'm going to be running specifically. Basically, I'm running the restake transaction, and I have in the interest of time, I've prepared a couple of stuff. But basically, I specify the network and my specific account. And as you can see here, this 204 is the pool ID. And we're going to execute this transaction. But first, let's make sure we see this. So just try to keep this in mind. Right now, the staking position is 1669.98, and we have $1,359 with 89 cents worth of assets here. And we have earned 0.110875, whatever, in staked flow. So, we could claim it here and do this whole thing manually, but that's kind of what we want to avoid. So let's just run this. All right. And boom, everything happened in an atomic manner. All the funds got received, they got swapped into the LP position, and then that LP token, we put it back into the farm. Let's look into what happened. So you see, everything, I'm scrolling through right here is exactly what happened in atomic manner, everything that we specified. So you can see how powerful this is. A huge, complex DeFi workflow has been done in a single transaction. Just one transaction was all it takes. And then you can, automate all of this. So yes, basically what you're going to see here through the events is the specific granular controls we are giving out, and then the specific transactions we are executing. For example, pulling the funds from the farm, like claiming them and then zapping them, and grabbing the LP tokens and putting it back into the farm. And then if we go back here, we're going to see, boom, you see, this has changed. It was 0.11 before, and now it's been reset because those rewards we were receiving, these rewards we were grabbing from here, we once again restaked it. So we auto-compounded this whole strategy. Now, I've showcased two things here: the scheduled transactions and the flow actions. You can see how this becomes very powerful when you want to optimize DeFi in general. Instead of having 20 different things 20 different protocols for 20 different assets, you can start automating these workflows. You can set up a scheduled transaction that will execute a flow action. And this way you can automate and optimize for your yields. But yes, these are the main things we have created here on the Forte upgrade. Another cool thing is that we now support natively bit 128 fixed math. So you can have a very granular control of detail for calculating interest and for general DeFi applications. Because those who have worked with DeFi before know how much of a pain in the head it is to be calculating that precision in decimals. But yes, please check out the documentation. I'm sure you guys are going to love it, and don't hesitate to contact us if you have any questions related to Forte or flow actions or scheduled transactions. Thank you.